Welcome to this explainer. We are jumping right in today, and I want you to mentally step away from our familiar, beautiful Earth for a second. Imagine those glowing city lights just fading beneath the atmosphere as we launch straight into deep space. Today, we're exploring cosmic facts so vast, so strange, and honestly so mind-blowing that they challenge our very understanding of reality. These aren't science fiction stories, folks. These are actual awe-inspiring discoveries made by astronomers. So buckle up, because this journey is going to completely change the way you look up at the night sky. Take a moment and picture yourself standing alone under a totally clear, dark night sky. You look up, you see thousands of stars shining above you, and it all looks so peaceful and familiar, right? Well, what if everything you can actually see with your own eyes represents just a microscopic fraction of the universe? Just beyond those familiar stars lies a cosmos packed with colorful nebulae, billions of shining galaxies, and phenomena that completely defy logic. Our goal today is to pull back that curtain and show you the true scale and mystery of what's really hiding out there in the dark. Part 1. Scale of the cosmos. Let's dive right into this by first wrapping our heads around the sheer, mind-bending size of our universe. It is so easy for our perception of size to just get totally shattered when we look beyond Earth. I mean, you probably think Earth is incredibly big, and to us, it absolutely is. But get this, more than 1 million Earths could fit inside our sun. The sun is this massive, roaring ball of plasma, but in the grand scheme of things, it's just an average-sized star. Enter UY Scuti, a red supergiant. If you took UY Scuti and dropped it right where our sun is today, its outer surface would extend all the way past the orbit of Jupiter. It would literally swallow Mercury, Venus, Earth, and Mars without a second thought. And that perfectly highlights the macro scale of our reality. Our home galaxy, the Milky Way, contains hundreds of billions of stars, but that is just our local neighborhood. When advanced observatories scan deep space, they estimate there are hundreds of billions of galaxies in the observable universe, and each one of those galaxies contains billions of stars, many with their own planetary systems. The sheer volume of worlds out there is so massive that the human mind actually struggles to even comprehend the math. We are essentially a tiny speck on a tiny speck floating in an infinite ocean of light. Part 2. Gravity's extreme landmarks. Let's keep moving and see what happens in regions where gravity entirely breaks the rules of physics. Imagine a colossal black hole, complete with a glowing accretion disk violently bending the very light around it. These monsters form when massive stars collapse under their own gravity. Right at the center of our Milky Way sits a supermassive black hole named Sagittarius A star. The gravity there is so strong that not even light can escape its pull. But what happens if you get too close? Well, scientists actually have a highly technical term for it: spaghettification. The difference in gravitational pull between your feet and your head would become so extreme, you'd be violently stretched out into a long, thin string of atoms, literally like a piece of spaghetti. And if being turned into cosmic pasta wasn't strange enough, consider what happens to time itself. Thanks to Einstein's theory of relativity, we know that time moves more slowly in stronger gravitational fields. This gravitational distortion creates a massive time dilation effect. If you were to spend just a few hours in a spacecraft hovering near the immense gravity of a black hole, years or even decades could be passing simultaneously back on Earth. You would essentially be time traveling into the future just by hanging out in the presence of this cosmic giant. Now, not all dying stars become black holes. Some collapse into these ultra-detailed, highly magnetic objects called neutron stars. A neutron star might pack more mass than our entire sun, but it's compressed into a sphere only about 20 kilometers across. To visualize how densely packed that is, imagine taking an enormous, towering mountain on Earth and physically squishing it down until it fits perfectly inside a single sugar cube. It's a level of density that shouldn't even seem possible, yet they're scattered all over the galaxy. Because a neutron star is so unimaginably dense, if you were to scoop up just one single teaspoon of its material, it would weigh a staggering 1 billion tons right here on Earth. The gravity on its surface is so intense that dropping an object from just 1 meter high would cause it to smash into the star at catastrophic speeds. It is just a wild cosmic reminder that nature can engineer conditions far, far beyond our wildest imagination. Part 3. Exotic worlds and life. As we fly deeper into space, past those gravitational monsters, we start running into bizarre exoplanets and cosmic structures in our ultimate search for the ingredients of life. At first glance, the exoplanet HD 189733b looks like this beautiful, deep blue marble, very reminiscent of our own Earth. But do not be fooled by its serene color. This is actually one of the most hostile places ever discovered. Those sweeping atmospheric patterns? Yeah, those are violent winds exceeding several thousand kilometers per hour. And because of the extreme temperatures, scientists believe it literally rains molten glass, and those sweeping winds blow those deadly glass particles completely sideways, creating a global shredding storm of liquid glass. But we also find miracles of creation out there. For the longest time, we wondered if water was just an earthly luxury. It's definitely not. Farther out, surrounding a distant black hole billions of light years away, scientists found an immense, glowing cosmic water vapor cloud stretching across space. And when I say immense, I mean it contains trillions of times more water than all of Earth's oceans combined. It is a gigantic floating reservoir of life's most basic ingredient. It suggests that the chemical building blocks for life are actually incredibly common throughout the universe. Which brings us right to one of the most haunting questions humanity has ever asked, summarized perfectly by the Fermi paradox. We've discovered thousands of exoplanets orbiting distant stars, and many of them sit right in the habitable zone where liquid water can exist. Statistically speaking, with hundreds of billions of galaxies out there, it's incredibly unlikely that Earth is the only place life emerged. Yet, despite decades of searching with our most advanced technology, we haven't found a single definitive trace of an extraterrestrial civilization. If the universe is absolutely teeming with habitable worlds, where is everybody? Are they too far away? Are advanced civilizations just exceedingly rare? Or are we just not looking the right way? Part 4. Time and the Unknown. Let's shift our perspective for a minute. To really understand our place in the universe, we have to talk about cosmic time and the mysterious, invisible forces holding all of these galaxies together. Because light travels at a finite speed, peering into space literally means looking into the past. Telescopes are essentially time machines. When you feel the warmth of the sun on your face, you're experiencing light that left it 8 minutes ago. The light from the nearest star to our solar system takes over 4 years to get here. So when astronomers use powerful telescopes to observe ancient galaxies evolving millions or even billions of light years away, they are observing ancient history. They are capturing light that began its journey long before human beings ever existed on Earth. Yet despite all these magnificent stars, planets, and glowing water clouds we've talked about, ordinary visible matter, meaning everything we can see, touch, or interact with, is just a tiny sliver of the universe. The vast, vast majority of our cosmos is made up of dark matter and dark energy. Dark matter is this invisible cosmic web that doesn't emit or reflect light, yet its gravity dictates how galaxies behave. And dark energy is even stranger. It's actively driving the accelerating expansion of the universe. The staggering truth is that the overwhelming majority of the universe remains completely unknown to us. Part 5. Made of stardust. Finally, let's bring our perspective all the way back to Earth, back to nature, and straight into the human body for the most humbling realization of all. How did we actually get here? Well, billions of years ago, massive ancient stars acted as cosmic furnaces, fusing basic building blocks into heavier elements. But those elements were trapped inside. It wasn't until those stars reached the end of their lives and exploded in brilliantly violent sequences called supernova that they scattered these newly forged elements across deep space. It was this explosive sacrifice that seeded the universe with the exact ingredients necessary to build planets, oceans, plants, animals, and eventually, us. Over immense, sweeping periods of cosmic time, those elements drifted, cooled, and came together to form our solar system. Which means your connection to the cosmos is not metaphorical, it is strictly biological. The calcium that gives strength to your bones, the iron pumping through your blood right now, and the oxygen filling your lungs as you breathe, every single one of these atoms has a direct cosmic origin. They were baked in the core of a star that lived and died billions of years ago. And this brings us to the ultimate takeaway of our explainer today. You are, quite literally, made of stardust. The universe is not some cold, distant place that exists totally separate from humanity. We grew out of it. We are a highly complex, intricately woven part of it. We are the universe, experiencing itself, forged in the glorious fires of ancient stars. It is perhaps the most beautiful and humbling realization science has ever given us. Which leaves us with this final, profound thought to ponder. As we bring our minds back down to our beautiful Earth beneath that star-filled sky, ask yourself, If we are fundamentally part of this incredible cosmos, what other mysteries about our own existence are waiting out there in the dark? The next time you step outside and gaze up at the night sky, remember, you aren't just looking at the universe, you are looking in a mirror. Keep exploring, keep learning, and thank you so much for joining me on this amazing journey.